Welcome to our Edu9 channel, and we are today going to discuss about a topic of sequence. What is sequence and what's the basics of sequence? So here in the board we are discussing about two sets. Set A is 1, 1.2, 1.1, 1.3, 1.9. So lots of numbers, and we can see that all those numbers are real numbers. This is their specialty, that all these numbers are real numbers, but they are not a particular rhythm. They are not in particular rhythm, because 1, then 1.2, then 1.1, then 1.3. They are increasing and decreasing, both here increases, here decreases, here increases, here increases, here increases, but decreases. So there is not a particular procedure. But similarly, if we consider the set B, where the elements are 1, 4, 9, 16, 25, all those are real numbers, but we can say that they are in a particular rhythm. What is the rhythm? We can see that these elements are 1 square, 2 square, 3 square, 4 square, and so on. So the set B is a collection of the squares of all positive integers. So we can define with a particular rhythm. This is the difference among them, and we can express this as a collection of particular rhythmic elements, and they can be denoted as by their nth elements. We know that the nth term of this set will be n square, but we cannot conclude what is the nth term of this set. So this is a sequence, but this is not a sequence. And now we are going to discuss about a mathematical or real analytical definition of sequence. Sequence, none other than a mapping F from n to r, where n is the collection of all natural numbers and r is the collection of all real numbers, and the set f1, f2, fn and so on is a subset of R. Obviously is a subset of R, and from here if we can find out the nth element, then we can say that by the definition of nth element we can find out the values of f1, f2, f3 and so on. So these are the sequence, and we denote this by fn within the second bracket, or un within the second bracket, or xn within the second bracket, and the range of the sequence will be fn, where n belongs to n. That is, this is the range of the sequence, f1, f2, f3. So collection of all those elements is called a sequence. Here are some examples of sequence, like example number 1, where un is a sequence, un equal to n, and n belongs to the set of natural numbers. So un equal to n, that is the nth term's value is n. So the elements of the sequence will be, when n equal to 1, then u1 will be 1, and u2 will be 2, u3 will be 3, u4 will be 4, and so on. This is the collection of the range set. This is the range of the sequence. And now the sequence un, where un equal to n by n plus 1. Then what is the range of this sequence? The first term, when n equal to 1, means 1 by 1 plus 1. That means 1 by 1 plus 1. When n equal to 2, then 2 by 2 plus 1. When n equal to 3, then 3 by 3 plus 1. When n equal to 4, then 4 by 4 plus 1, and so on. That is ultimately 1 by 2, 2 by 3, 3 by 4, 4 by 5, and so on. This is the range set. And in this sequence, the sequence un is denoted by minus 1 to the power n. That is, the nth term is minus 1 to the power n, where n belongs to the set of natural numbers. Then the range set will be, see, when the value of n is 1, then it becomes minus 1. When the value is 2, then it becomes minus 1 square, that means plus 1. Again 1, when the value of n is 3, then it will be minus 1 whole cube, that is minus 1. Again, when the value of n is 4, then it becomes 1 and so on. Ultimately, the range is -1 to 1, none other than. In the next sequence, un is a sequence where un is sin n pi by 2. Here, the values will be the range set when n equal to 1, that means sin pi by 2, that is 1. When n equal to 2, then sin pi, that is 0. When n equal to 3, then sin 3 pi by 2, that means -1 and so on. That is, the range set is ultimately 1, 0 and -1. In the next sequence, un is a sequence where un equal to 2, n belongs to n. That means nth term is 2 and the terms are not depending on n. So this is ultimate, all the elements are, all the values of the sequences are 2. So the first term 2, second term 2, third term 2 and all the terms are 2. That is, the range set is ultimately a singleton set 2. These are the examples of sequence. Now what is bounded sequence? Here we consider a sequence, real sequence un. This is said to be a bounded sequence if there exists two real numbers small g and capital G such that this relation holds, where small g is a lower bound of the sequence un and capital G is the upper bound of the sequence un. Suppose we consider an example un as a sequence defined by 1 by n. So the elements of the sequence are when n equal to 1, then 1 by 1 means 1, when n equal to 2, then 1 by 2, when n equal to 3, then 1 by 3, 1 by 4 and so on. That is, all the values are going towards 0. So, but the element 0 must not be included in this set. So we can see that the maximum value of the sequence is 1 and the least value is tends to 0 but not equal to 0. So here we can see that the lower bound can be stated as 0 and the upper bound of the sequence is 1. So we can find the fixed lower and upper bounds. So this is a bounded sequence. Now we are going to discuss about the topic limit of a sequence. What is about limit of a sequence? Suppose we consider un as a real sequence, then the mathematical definition is a real sequence, real number L is said to be a limit of a sequence un if corresponding to a pre-assigned epsilon greater than 0, that is positive epsilon, there exists a natural number k which is depending on epsilon such that mod of un minus L is less than epsilon when for all n greater or equal to k. And what is the explanation? Let us discuss with an example. We consider a sequence un which is as 1 by n and consider a real number L as 0, because we can see that the elements of the sequence ultimately tends to 0. Why? 1 half, 1 by 3, 1 by 4, 1 by 5, 1 by 6, those are the elements of the sequence. That is, both the elements are continuously decreasing and going towards 0. So we consider the value of L here as 0, and now we consider a value of epsilon as 3.7. Anyone can choose whatever they want. The values are not restricted. Okay, and now we have to prove that this is less than 3.7. Okay, and for this relation will be satisfied few of the values for some of values of n which is greater or equal to k. So if we see that when the value of n equal to 1, then this becomes 1 minus 0, that is 1 which is less than 3.7. When the value of n is 2, then this becomes half minus 0 which is less than 3.7, and so on. All these values are less than 3.7. So we can see that all those terms are satisfied. So this is, from this we can conclude that 0 is a limit of the sequence. Suppose if anyone wants to choose epsilon as very small, suppose we consider the value of epsilon as 0.01. Then for u1 minus 0, that is u1 means 1 minus 0, which is not less than 0.01. Similarly, when u2 half, that is 0.5, which is also not less than 0.01. But continuing in this process, after some time, when the value of comes to 1 by 101, that is the term number u101 minus 0, which is obviously less than 0.01. So the relation is satisfied when the value of n is 101. So here the value of k is greater equal to 101, and in this case we can see that this relation is satisfied from the beginning. So here we can see that the value of k is greater equal to 1. So these values of k are varying depending upon epsilon. Here we choose the value of epsilon as 3.7, so we get the value of k 1, and here we choose the value of epsilon as 0.01, so we get k 101. All those are natural numbers. If we can find out such values of k for each positive epsilon, then we can say that the sequence un must have a limit L. Here the sequence 1 by n has a limit L equal to 0. Now our question, now we can see that a node as a sequence can have at most one limit. So this means that a particular sequence like 1 by n have at most one limit, that is 1 by n have a limit 0, but it must not have any other limit like 1 or half, 1 by 3, etc. Okay, so the sequence 1 by n has only one limit, that is 0. And now the concept of convergent sequence. What is convergent sequence? If a sequence un has a particular limit L, a real sequence un is said to be a convergent sequence if it has a limit L belongs to R. Here we can see that the above sequence un, that is 1 by n, which has a limit is 0. So we can say that the sequence un 1 by n is a convergent sequence and it converges to the limit 0, and we can write it as limit n tends to infinity un equal to L. This is the concept of convergent sequence. Now here we are going to discuss an example. Prove that n square by n square plus 1 is a prove that n square plus 1 by n square is convergent to 1. For that we consider a pre-assigned epsilon. So this result must hold as it converges to 1. So we are going to check whether the result holds or not. So n square plus 1 by n square minus 1 will be less than epsilon if this result holds. So 1 and 1 cancelled out. So 1 by n square must be less than epsilon, and modulus symbol is omitted as 1 by n square is a square quantity, so it must be a positive quantity. So 1 by n square less than epsilon implies n square greater than 1 by epsilon, so n is greater than 1 by epsilon. So we have to find out the value of k for which the result holds. So we consider the value of k as this, because n is greater than 1 by mod epsilon. So the next value of a natural number which is greater than 1 by root epsilon will be box of 1 by root epsilon plus 1. That is why we choose k in such a way. So n square plus n square plus 1 by n square is a convergent sequence and converges to 1. And for example, if we consider the value of epsilon as 0.01, then the value of k will be 1 by epsilon plus 1. The epsilon root 1 by root epsilon, so root epsilon is 0.01's root. That means this will be returned as 10, and 10 plus 1 means 11. This is the value of k for this particular epsilon, and we can find out the values of k in such a way. And there is a note that a convergent sequence is bounded. Every convergent sequence be always bounded. You can see that in this case, this is a convergent sequence, and the upper bound of the sequence will be 1, and the lower bound of the sequence will be 0, minus 1, minus 2, and so on. But a bounded sequence may not be convergent. Suppose, for example, we consider a bounded sequence minus 1 to the power n. What is it? Like first term minus 1, 1, minus 1, 1, minus 1, 1. Repeating these types of values, and this called oscillatory sequence, minus 1, 1, minus 1, 1, minus 1, 1, and those oscillatory sequence are not convergent. So this is a bounded sequence which is bounded by minus 1 and 1, lower bound is minus 1 and upper bound is 1. So this is not a convergent sequence, but this is a bounded sequence. Here we are going to discuss about some important results. Like un and vn are two convergent sequences where un converges to u and vn converges to v. Then the limit of un plus vn is u plus v. That means actually the un plus vn sequence is convergent to u plus v. Similarly, if a constant is k, then if we multiply a sequence un by that particular constant, then the limit of that sequence will be k into u. So this implies that the sequence kun is converges to ku. Similarly, the sequence un and vn, that is two convergent sequences, are multiplied with each other, then the new sequence un vn must be a convergent sequence and converges to the number uv. Again, if we consider a sequence un by vn, it will be convergent to u by v provided v must not be 0. If v is 0, then this result must not hold, and so on.